So when we were talking about functions, remember we had things that looked like this, right? So instead of writing y equals x squared plus 2, we wrote the function of x is x squared plus 2. Oh, John, you're in the room. Delete. Okay, so I was wondering why you had your laptop open. Okay, so when we have things like this, give me an idea. You should know off the top of your head what this graph looks like. What does this graph look like? It's a... Okay, good. This is exactly the same as the positive quadratic we looked at, but instead of going through the origin, it goes through 2, right? All we did is shift it up 2. We should know that sort of stuff. So when we're looking at things like this, we're saying the function of x is this. So what if I said the function of 3? What does that mean? X is 3, right? All I'm saying is that 3 squared plus 2, and that is 11. So that means there is a point on this graph that is 311. So this point here is like 311, okay? So you can substitute any x value in, get your corresponding y value, and you're finding the function at 3, all right? That's the terminology you're going to see. You're also going to see things like this.
Oh.
Right, you've got like a weird double R thing. Obviously, I'm a bit rubbish at drawing it. This means that x is all real numbers, okay? So you're going to see this a lot. So what they're going to do is they're always going to specify the allowed values of x. If they say this, it means x can be anything apart from unreal numbers. What do we know about unreal numbers? What are they? What? We've just been dealing with them. Square root of negative numbers, right? So if I'm square rooting something that's negative, that is a non-real number. And so we're not allowed to include those in this, okay? So basically any answer that makes sense is fine. So sometimes though, you will be told that x is less than or equal to 3. You're going to have restrictions on your functions. So you need to take that into account, especially when we're graphing. So we are also going to use some new notation where we're going to say things like, so I'm going to write this one again. F is such that x maps onto x squared plus 2. That's what this means. So F, we've already used these double things. We did that in set notation in IGCSE. So the function is such that x maps onto x squared plus 2. Okay, so that is some of the things that we're going to... So if you see this, it means this, right? It means the same thing. It's just another way of notating. So we just need to get used to the way that they're going to write things. And again, we can say all sorts of things. Okay. There are multiple types of functions. First of all, let's save that so I don't get rid of it.
Okay.
All right. So we have multiple types of functions. We have things called one-to-one functions, which is some, oh, whoops. So that is something like linear equations, right? Yeah, right. Yeah. All right. So if I have something like, let's use their notation. Oh, actually, let's just stick with this for now. So if I have something like f of x is such that 2x plus 1, right? If I then have some x values here of like -1, 0, 1, and 2, what I can do is I can say that f of x, the function of x at -1 is -1, right? 2 times -1 is -2, plus 1 is -1. What about when x is 0? 1. When x is 1? 3 and 2, 5. Good. Okay, you can see here that every x value has one corresponding y value or functional output, right? So we can also call this the input and this is the output, right? So the output is always going to be y, the input is always going to be x. Why is there an output? All right. So this is a one-to-one function. Every input has a separate, different output. Now, give me an example of something that's going to have multiple outputs. Right, something with x squared. So let's make my function x squared minus 3. Okay, so my x and my function of x, let's say that I have -2, -1, 0, 1, 2. All right, what is my function here? 1, right? -2 squared is 4. 4 minus 3 is 1. What's it here? What's it here? What's it here? -2. And here? 1. Now, right, so this is going to be a curvy graph. So now you can see that 2 maps on to -1, right? So these are the same answers. This guy gets his own thing. What is this? What does that mean this is? Turning point. Excellent. So these guys also match up. They're both -2. So this is called one to many, right? So each x can have many different options. That will be true for an x cubed graph as well, right? Each x has multiple y. Oh, sorry. Yes, sorry, I said it backwards. So each y has multiple corresponding x values, right? So if it's the other way around, if you have, so the problem with that is it's not a function anymore. So if it's something, this is obviously something like that, whereas this is something like that. If you had a many to one function, it would be like that, right? Because you would have multiple y outputs, sorry, multiple x values for each y output. And so we say that that is not a function. So, oh, I've actually said it backwards. I am so sorry. It is many to one, not one to many. I have said it backwards. I know, I'm the worst. Okay, this one is many to one. It's the other one that doesn't work. Okay. Blah, blah, blah. So if it is the other way around, it is not a function, okay? So you're allowed to have a U shape, you're not allowed to have a C shape, okay? So we don't want sideways graphs, but we're okay with y's having multiple x's, but not x's having multiple y's. We're not okay with that. All right, let's save that. So let's now look at how we can restrict functions given a domain. So what do we know about domain and range? Those are familiar words to us, but we haven't used them for a while. Okay, people who've taken this class before, what's domain and range? Perfect. So domain is the possible x values, range is the possible y values. You are going to be given restrictions, especially on your domain, and then you're going to be asked to find the corresponding y values. All right, so let's do an example of what that might look like. All right, so if I have f of x is, let's do a really easy one, x plus 5, right? Where x is greater than or equal to 5. I am being told what my domain restrictions are, and I want to know what my corresponding y restrictions are. So if I was to draw this graph, x is not allowed to be anything less than 5. So when x is 5, what's y? 10, right? So that means, am I going to go up or down from here? Up, right? This is a positive linear graph. So that means y must also be greater than or equal to 10. These are my range restrictions given my domain restrictions. Okay, what if I give you different domain restrictions? Let's give you a start and a finish. So I'm going to tell you that you're only allowed to go, actually, let's do a different graph. Let's do x cubed, okay? So the function of x is x cubed, and I'm going to give you a start and a finish. So we're going to go between -2 and 4. So what I need to do is figure out what my range is at this end. So what's my range when x is -2? -8, good, because I'm cubing a negative, so it goes back to being negative. And then what happens when I get to 4? Okay, so my range restriction is between -8 and +64. Does that make sense? So I'm really just plugging it in and finding my output. Now, what happens is when we put multiple functions in the same thing, and I'm going to restrict each one and make them join up. Okay, so I'm going to have one function to here, then I'm going to start with a new function and keep going. All right, so I am going to start with, we're going to start seeing some new things. All right, so I'm going to have two different functions. I'm going to have 4 minus x, and I'm going to have 2x plus 1. So what I want to do is I want to work out both of these, but I think when it does that, I'm going to be given domain restrictions for both of them. And then this one is going to be between 1 and 3. So what I need to do is work out what it looks like here. And then when I get to 1, I swap to here. What does it look like here? All right. No, you might have gaps. Yep, totally. You could totally do that. And in fact, I'll give you an example where there is a gappy one. All right, so let's have a look at here. When x is -2, what is my y value? How did you get 6? Yeah, 4 minus -2, right? That becomes 6. What happens when it's 1? Okay, so I get between 6 and 3. What happens here? 3. Okay, so I've got my corresponding ranges with my domains. Now what I can do is graph this. So if I'm going to graph, leave me alone. All right, so 1, 2, 3, 4, 5, 6, 7. We need to go all the way up to 7. And I need to go between -2 and 3. All right, so this graph starts at -2 and 6, right? That's that point. And then it finishes at 1 and 3. So 1 and 3. My next graph starts at 1 and 3, which is here, and goes to 3 and 7. So because this is a linear graph, I know these are perfectly straight lines. So I'm going to draw a straight line between there and there. And nope, I'm moving that point by accident. And then I'm going to, give me my straight line tool. I'm going to draw a straight line between those two things. Sure. We're going to pretend those are lovely straight lines. Okay, so again, we're just graphing two different bits. We're finding the sections we're allowed to graph. And this is the graph of these two separate functions that work together. All right. Let's have a look at one where we don't need to draw a graph, because we don't always want to draw a graph. If it says draw it, great, draw it. If it doesn't, don't waste your time. We don't like drawing graphs for no reason. They are time consuming. So let's look at something terrible and let's use completing the square, which is what we've just done. So